Hello dear student, I am Mondo Islam. Today's in the video we are going to discuss an important question from CSIRNET June 2021. Okay, this is question from linear algebra. This is basically a question from part C, and this is 4.7 right mark. Question ID is 5.24, question 5 to 4. Okay, they are asking which of the following are inner product, and there are 1 to 4 options given. Okay, so for the question I am first giving a result. Okay, this result is taken from artisanal algebra book. Okay, and this result is very helpful to solve this question 1 to 4. Okay, if you know this result, then you can solve this question within 2 seconds. Okay, so let us write first the result. Okay, then we are proceed to solve this question. Okay, so what is the result? Result is this: let a equal to a1 a12 a21 a22 b a m2 belongs to m2r. M2r means is a two question matrix, each entry a real number. Okay, let x comma y equal to vector two column vector x1 comma x2 belongs to r2, means x1 x2 is a real number and it's a two constant vector. Okay, y equal to y1 y2 belongs to r2, means it's a two constant vector and each entry a real number. Okay, then if x comma y equal to y transpose ax. Okay, if you break this, what is by x, then what you get? If you break this is column vector, so if you break this row vector. Okay, so y1 y2 here the matrix in place a11 a12 a21 a22 x1 x2. Okay, multiply this, you get a1 y1 a22 y2 a12 y1 sorry a1 y1 a21 a1 y1 a21 a1 y1 a21 y2. Okay, this a21 y2 a1 to y1 a22 a22 y2. Then you have to multiply with x1 x2. Okay, this is 1 goes to row vector and 2 goes to column vector. If you multiply this, you get a real number. 1 cross 1 means it is a real number. So what do you get if you multiply? If you multiply a1 x1 y1 a21 x1 y2 a12 x2 y1 and a22 x2. Hope you now understand what I am going to do. Okay, because you so if seeing this is similar, then let the person have asked. Okay, actually in artisanal book fx is also given, is from inner part. Okay, for my convenience I break this to compare the result. Okay, with my question. So this fx y, or you can say this y plus by x, form an inner product. Okay, form an inner product. There are 4 conditions. I'm reading the upper part. Okay, it is not needed. This form an inner product. This fx y, or you can say if you break it this expression, form an inner product. This form an inner product. Form an inner product. Inner product on R2. If on R2, if and only this condition, if only, okay, strong condition. Okay, if only condition is strong condition. First of all, matrix is symmetric. There are 4 conditions. First of all, matrix is symmetric, means A transpose equal to A. Since it's 2 cross matrix, so it implies A21 equal to A12. Okay, 2 cross matrix, so symmetric means A12 equal to A21, and A1 should be positive, and A22 should be positive. And third condition, there are 2 conditions, first, second, third, and fourth condition is determinant should be positive. Okay, matrix determinant should be positive. If this 3 conditions satisfies, okay, then we can say the fx y equal to y plus x, or you can say this expression a1 x1 a1 x1 y2 a1 to x2 y1 if is from inner product. Okay, so using this result we are going to solve this question within 2 seconds. Okay, if you know this result, then the question is very easy for you to solve. Okay, so I am So I'm going to option by 1. Okay, option 1. You have to basically write the matrix and see. You have to see whether the matrix is symmetric, A1 positive, A2 positive, and determinant positive. Okay, if it satisfies, then it's in a box. Okay, no problem. So you have to write the matrix for each option. So I am going to write option 1. For option 1, I am going to write the matrix. Okay, here you have to take in the variable, because variable x and y. So in left you have to place x1, x2. In right upper part you have to place y0, because y vector is component is y0. Okay, so in this place x1, y1 coefficient will be occur. Okay, I'm going to writing for option x1 will coefficient 1. So in this place it's 1. In this place x1, y2 will coefficient, x1 coefficient 2. So in this place you have to place 2. X in this place x2, y1, x2 coefficient will be 2. So x2 and 2 and x2, y2. In this place if you write the coefficient x2, y2, x2, y2 coefficient will be 1. So this is 1. If you observe this matrix is symmetric. Okay, because a1 equal to a21 equal to 2. So matrix is symmetric. First condition is satisfied. Okay, matrix is symmetric and first condition is satisfied. Second condition a1 positive, a22 positive. Here both positive. Okay, here a1 is 1 positive, a22 is 1 is positive. Okay, and matrix determinant should be what? It should be 1 minus 4. 1 minus 4 means minus 3. It's going to be negative, but we need the determinant to be positive, but here we see that determinant is negative, so it does not form an inner product. Okay, because the condition is if only. So you have to discard option 1. Option 1 is not correct. Now for option 2, similarly we are going to write the matrix for option 2. If you write the matrix for option 2, see here coefficient of x1, 1 will be occur. Okay, because here x1, x2, y0, coefficient x1, 1 will occur. This one coefficient x1, y2, 1, 1, 1. Coefficient x2, y1, this also 1. Coefficient of x2, y2, this also 2. Okay, so the matrix is symmetric. Okay, because a1 equal to 1 equal to a2, a1 2 will be 1 and a2 1, both 1. So matrix symmetric. Also a1 positive. Here a1 second condition, a1 will be 1 positive, a2 2 will be 2 is positive, but third condition determinant is 2 minus 1 positive. Okay, so both it's both conditions. Third so for this the matrix satisfies also satisfies the third the three conditions also. Okay, first of all matrix symmetric, a1 positive, a2 positive, and also determinant is positive. Okay, so since it's all condition, then we can say that it form inner product. Okay, this is the result. Now we are going to writing the matrix for option 3. So yes, now we have shown that option 1 is incorrect, option 2 is correct. Now left are option 3 and option 4. Okay, so see what option 3 says. For option 3 I am going to write the matrix A. Matrix is, you have to place here x1, x2, here variable is y and 2. Okay, so you have to take the coefficient of x1, y1 here, coefficient x1 coefficient 1, coefficient x2 x1 y2 will be here 1, coefficient x2 y1 will be here 1, coefficient x2 y2 will be 1. Okay, in this case all are 1. Okay, so you have to write 1. See the matrix is symmetric, a1 equal to a, since a1 2 equal to a2 1 will be 1, the matrix is symmetric. Okay, here a1 will be 1 positive. Okay, a2 2 will be also 1 positive, but so both 1 2 conditions satisfied. The result, but determinant is, if you see this 1 minus 1 determinant is 0. Okay, the determinant is not positive, it is not satisfied. So you can say this doesn't form inner product, because the condition is if only. So if one condition fails, then it doesn't form inner product. Okay, if it's not if only condition, then you can say, because since the condition is if only, so if one condition fail, then it doesn't form an inner product. So yes, now we get option 1 is correct, option 2 is correct, option 3 is incorrect. Now left option 4. Option 4. For option 4 we are going to write the matrix. Okay, you can write this like is vector x is y. Okay, also you can write this like this form I write y transpose x. Okay, where y is a vector y and y2, and x is a vector x1 x2, and a is the matrix that I am going to write x1 x2 variable here y and y2. In place you have to write the coefficient of x1 y1, so coefficient of x1 will be 1. Okay, so you have to write here 1. Coefficient of x1 y2, this will be minus half, so minus half. Coefficient of x2 y1, this will be minus half, so this is minus half. Coefficient of x2 y2, this will be 1. Okay, so this is matrix symmetric because a1 and a2 both half. So for the matrix, if you observe a1 2 equal to a21 both minus half equal, so matrix symmetric. Matrix is symmetric. First condition satisfied. Okay. Second condition a1 positive, a1 is half 1 positive, a22 is 1, this also positive, so second condition satisfied. Third condition determinant is positive. Okay, determinant 1 to 1 minus 1 by 4, 1 by 4 means 3 by 4 is positive, so all conditions satisfied. Okay, satisfy all condition. So using the result we can say the fourth option is correct, and this can form an inner product. Okay, so fourth is correct. Okay, so for this question we can say option 1 is incorrect. Okay, option 2 is correct, option 3 is incorrect, option 4 is correct. So correct option are option 2 and 4 are correct. Okay, 2 and 4. So for the question option 2 and 4 are correct. So if you have any doubt, you can always ask in the comment section. Okay, and the more video more solution will come in the upcoming videos. Okay, so thank you.